Hi, Assalamualaikum and good day. We are from group 2. Now we will present for experiment 2, which is investigation of flow patterns over different immersed body. And I am Nur Aisyah binti Saadun, MA18049. Now I will present about chapter 1, which is introduction. For the introduction of the experiment is basically an understanding of fluid flow over immersed body and how a flow behaves when it goes over it. So in this experiment, we are required to do two type of experiment, which is flow over immersed body and the boundary layer. So the effect of turbulence, flow separation, angles to the flow are seen from the streamline formation on the bodies that we'll discuss in this complete lab report. So for the both experiment, it is to determine the velocity distribution for flat plate and the boundary layer thickness subjected to longitudinal flow for rough and smooth surfaces. After getting the result of data, the calculation are needed for each plate of plates. So after we do the calculation, we use the formula, which is formula for velocity and Reynolds number. So the Reynolds number are used to understand the variation of the flow between the laminar and turbulent flow. Next, I will explain about the objective of the experiment. So first objective is to estimate the drag force exerted on immersed object of different drag bodies at different velocity. So second objective is to measure the boundary layer properties for the measured velocity profiles. Third, to measure the boundary layer velocity profile and observe the growth of the boundary layer for flat plate with smooth and rough surfaces. And last objective is to analyze the effect of surface roughness on the development of boundary layer. Okay, third, I will explain about the background of the experiment. So in this lab, we require to do two experiments purposely to test and verify the theory of boundary layer when flow over a flat surface and flow over the immersed body. So the experiment was conducted to identify the factor that can affect the boundary layer and the profiles. Besides, the experiment are used to observe the relation of velocity, roughness to the Reynolds number. So from the experiment, the phenomena of laminar flow and turbulent flow also can be observed through the experiment.
Assalamualaikum and hi everyone. My name is Nur Syafiqah binti Nur Sofyan and my matrix number is MA18034 and I'll be continuing the presentation with the literature review and theory part. So we are going to the first topic, which is the flow over an immersed body. So it is happen when a solid body is hold on to the path of the moving fluid and it is completely immersed, and besides the body will subjected to some pressure and force. And as there are flow over the immersed body, therefore there will be a streamline formation over the bodies, and this streamline body shape is helped to reduce the frictional force that happen in between the fluid, and it is function to reduce the speed of the motion of the movement. So next is flow separation, also known as the boundary layer separation, and it happens at the thickest part of the streamline body, and it occurs when the speed is lower but the pressure is high. And other factor that affect the streamline body flow is the angle of directions. So angle of directed is subjected to some pressure, and the pressure component is divided into two components, which is lift and drag. So the pressure component at the right angle of the direction is known as lift, while the force that opposite the direction of the fluid flow or motion is known as drag. So next we are going to the boundary layer, which boundary layer is the layer of the fluid which the viscosity effect is notable, and this layer is tends to attach with the surface. So there is two main category, which is the turbulent flow and the laminar flow. So for turbulent flow, it contains swirls or eddies, but for laminar, it a very smooth flow. And the flow pattern can be predicted by using Reynolds number, which laminar flow contain low Reynolds number, but for turbulent flow, it contain high Reynolds number. So last but not least, this other factor that affect the boundary layer is the surface roughness, and in many situations, a surface that is rough is tend to develop the turbulent boundary layers. So that's all from me. Thank you.
Assalamualaikum and good day. I am Nuraina. So now I'm going to explain for the methodology of our experiment. There is two experiment, which is the first experiment is flow pattern of symmetric aerofoil at different angle of attack, and the second experiment is boundary layer of a flat plate. As you can see, this is the apparatus that will be used for both experiment. Okay, and figure below show the component listed in airflow bench apparatus. For the first experiment, the flow of the air can be clearly seen from the front view of the circle image below. Now, this is the apparatus setup and procedure for our first experiment, where the experiment was repeated for three different angles of attack, which is 0 degree, 30 degree and 45 degree. Next, for the second experiment for boundary layer of flat plate, listed below was the apparatus and step required to perform the second experiment. In this experiment, there will be two types of plate, which is the rough plate and smooth plate. All the data were collected and recorded in the table given. Following that, every experiment was conducted by following all the required precautions for safety purposes.
Good day everyone, my name is Sararasan of Karthikeya. So today I'm going to present about the result part. This is the recorded height for smooth surface and recorded height for rough surface. From this we can calculate the velocity. This is the calculated velocity for smooth surface and rough surface. This one is we calculate by using the formula given by our lecturer. And then this is the from the table we produce the graph, speed distribution for smooth surface and speed distribution for rough surface. From here we can conclude that velocity is increased with the distance, and also rough surface is higher than the smooth surface. Let's move on to the discussion. Explain about the boundary layer thickness in the boundary layer of both surface. The height of the surface roughness on a flat surface is quite tiny, therefore it often overlooked. This is because the flow smooth surface condition will unaffected by the roughness because the disturbance is so minor. The second one is what is the distance in the plate before the flow become turbulent. What phenomena could be the reason for these changes. When fluid flow along a flat plate, there will be a laminar and turbulent flow over it. The point or location when the flow from laminar turns turbulent is called the critical location. The critical location can be calculated using the Reynolds number formula, substituting Re with 50,000 where the flow is becoming turbulent. What are the difference in terms of result and smooth and rough surface? At x equals to 50 millimeter, the velocity and Raymond number for rough surface and rough surface are higher as compared to the smooth surface, but the manometer height for smooth surface are higher compared to the rough surface. This can be proven when the boundary layer thickness is 4.175 millimeter. The manometer height for smooth surface is 234 millimeter, while for the rough surface is 220 millimeter. That's all from me. I pass it to my friend. Thank you.
Hello everyone, my name is Silantre. I'm going to discuss about the result that we obtained during the experiment about the flow over immersed body. What is flow over immersed body? We see that when a solid body is held in the path of a moving fluid and is completely immersed in it, the body will subjected to some pressure force. According to Newton's law of resistance, the force exerted by a moving fluid on an immersed body is directly proportional to the rate of change of momentum due to the presence of the body. Next, these are the flow patterns of the cylinder, flow pattern of orifice, flow pattern of wing profile at the angle of 0 degrees, and the flow pattern of a wing profile at the angle of 30 degrees. We obtained this flow pattern during the experiment. As we can see, there are turbulence and eddy current, Next, which body creates the most smooth streamlines? Wing profile at the 0 degree creates the most smooth streamline. In that angle of wing profile, the eddy current is not occur and the streamline of flow straight without any disruption. Hence, the wing profile at the 0 degree angle has the most smooth streamline. Next, what does a smooth streamline portray? Smooth ordinary airflow patterns around an object are referred to as laminar flow. They denote at the very least disturbance of the air by the object's motion through it. Streamlining, then, is the contouring of a plane or a different body in such a way that its turbulent wake is decreased to minimum. What happens to the wing profile at 30-degree angle compared to the normal? The angle of attack is the angle among the line of the chord of an aerofoil and the relative airflow. Higher angle of attack will create extra lift. However, there is a restrict to that angle that is known as critical angle of attack. This is generally 17 degree. If the angle of attack exceeds the critical angle of attack, an excessive amount of drag pressure can be created and could lower the lift pressure due to the fact extra surface area is exposed perpendicularly to the fluid in preference to the fluid travels through the aerofoil and developing lift force. What phenomenon causes the orifice flow to disperse? From my knowledge, orifice plates are used as a restriction device to adjust fluid flow or reduce the flowing pressure downstream of the orifice plate. The use of a fixed restriction orifice may be useful and economic by lowering the needs on different flow system components. Since the flow of liquid is confined by the orifice, it follows the pressure that exit side of the orifice is less than that at the inlet side. But that is depending on the most effective true if there is a liquid flow. A smaller upstream orifice prevents sufficient liquid flow to obtain better pressure.
After we get the result and discussion, we come out with the conclusion, which is we divide into two parts. Part 1, boundary layer. Part 2, airflow over immersed body. So for the conclusion for boundary layer, this experiment was identified the properties of boundary layer over a flat surface by observation of velocity of fluid, Reynolds number, and roughness of the flat plate. The value of Reynolds number depends on the roughness and the velocity of the surface. Based on the experiment, the rough surface may produce a high Reynolds number and velocity. Okay, for part 2, for the conclusion, this experiment was proven that the streamline profile was affected by the shape of immersed body and angle of the immersed body relative to the speed of wind and wind direction. The experiment also proved that a high Reynolds number will increase the drag force because drag force is directly proportional to Reynolds number. That's all from our group. Thank you.